Hi, my name is Muhammad Rahmat. My metric number is 2025111937. Now I want to explain about differentiation is a fundamental concept in calculus that describes how a quantity changes with respect to another quantity. In most cases, we use differentiation to determine how a function y changes when the input variable x changes. The result of this process is called the derivative. The derivative tells us the rate of change of a function or the slope of a curve at a specific point. In simple terms, differentiation helps us understand how far something is increasing or decreasing at any moment. For example, if we know an object position over time, the derivative of that position gives us the object instantaneous velocity. There are several techniques used to differentiate different types of functions. The first technique is the power rule, which is used for functions involving power of x. Next is the constant rule, where the derivative of any constant number is 0. We also use the constant multiple rule when a constant is multiplied by a function. Another important technique is the sum and difference rule, which allows us to differentiate functions that are add or subtract. For functions that involve multiplication, we use the product rule, while functions written as division require the quotient rule. When dealing with a composite function, where a function is inside another, we apply the chain rule, which is one of the most essential techniques in calculus. That's all. Thank you.
Assalamualaikum. My name is Ahmad Faiz Arfan bin Muhammad. My student ID is 2025194295, and in this video I will be explaining how to find the derivative for question 2a and question 2b. The purpose of this explanation is to demonstrate the correct use of the product rule and the question 1. For question 2a, y equals to 9e power of x times x minus 3. The function is multiplication of two expressions. Therefore, we use the product rule, which states dy over dx equals to u prime v plus u v prime. First, I identify the two parts, u and v. U is 9e to the power of x, v is 10x minus 3. Now, I differentiate each part. Derivative of u prime equals to 9e to the power of x. Derivative of v is v prime equals to sec square x minus 3. Then I substitute them back into the product rule formula. Dy over dx equals to 9e to the power of x sec square, open bracket, x minus 3, close bracket, plus 9e to the power of x, tan open bracket, x minus 3, close bracket. I can factor out 9e to the power of x. So the final answer is dy over dx equals to 9e to the power of x, open bracket, sec square, x minus 3, plus tan x minus 3, close bracket. For question 2b, y equals to x squared plus 1 over sin x. The function is in the form of a fraction, so I use the quotient rule, which is dy over dx is equal to vu prime minus uv prime over v squared. Here, we identify it into two parts. U is equals to x squared plus 1 and v is sin x. Now, I differentiate both parts. Derivative of u is u prime equals to 2x. Derivative of v is v prime over 2 cos x. Then I apply it into the quotient rule. Dy over dx equals to open bracket sin x close bracket, open bracket, 2x close bracket, minus open bracket, x squared plus 1 close bracket, open bracket, cos x close bracket over sin x squared. This is the complete answer for question B. In conclusion, this question shows how important it is to choose the correct differentiation method. For question 2a, we use the product rule, and question 2b, we use the quotient rule. By identifying the form of the function first, the steps become much easier.
Hello, my name is Sharif Aswad. I'll be solving my part as for question 3. So we are given a function of ln y plus sine square in bracket x square plus e to the power of y equals to 5xy using implicit differentiation. So the first step to solve this kind of equation is I will let the dy dx to be any variable first. Don't have to put too much effort into the working. And then the next function I'm going to let is in the bracket x square plus e to the power of y to be u. The next step is to identify every function in this equation and differentiate every of them. So as we pointed out all the function here, let's find all the derivative of them. So the ln y is a ln function, so it's like ln x. When we differentiate ln x, it is 1 over x. But this time it's different because we involve y, so we need to multiply the 1 over y with m as we let the dy dx to be m. The second function is sine square u. This is a composite function, but I'm not here to recognize and pull out the composite function because it will consume too much time to find the derivative of it. Just simply put out the two functions like this, the outer one and the inner one. The outer one should be sine square u and the inner one should be sine u. And then differentiation sine square u should not be a problem. We bring the power to the front and then minus the power with 1. So it becomes 2 sine u. And then for the sine u function, we use the chain rule. It should be sine u equals to cos fx and fx prime, which is the fx refers to u. So we got cos u times u prime. So we can write it down as 2 sine u cos u prime. But trigonometry rule say that 2 sine u cos u can be written as sine 2u. The derivative of 5xy. This is also a composite function, the product of two functions. For this one, we use the formula v u prime plus u v prime. So we recognize which one is v and u first. We take 5x as v and we write down 5x, u as y, and then we prime the y. The y should be cancelled out when we differentiate it. And then we still multiply with dy dx, which is we let it into m. And then for the uv, the u, just write it down the y. You don't have to change anything of it. So just differentiate the 5x. That should be 5. So this is the derivative of 5xy. And then the next step is for you to substitute back the bracket x squared plus ey as u. And then we solve for the x squared plus ey prime. We differentiate everything inside the bracket. For the x squared, it becomes 2x. And the e to the power of y becomes e to the power of y, as we just bring the coefficient of y to the front, which is 1, and it changes nothing at all. But still involve the function y, so we need to multiply it with m. Now we have the question here, but we want the m to be on the outside and solve for m. So we expand sine 2, the bracket function, with 2x, and then sine 2, the bracket function, with e to the power of y multiplied with m. Finally, we took the m out of there. Now we can rewrite it into the full equation. So for the last step is for you to solve for m. So we solve for m first. We put all functions that multiply with m to the left side and the others on the right side. So we can factorize the m. Well, we can easily factorize as all the functions that multiply with m is already on the left side. So what we can do is bring the whole bracket to the right side. Now we just need to substitute back dy dx to m and simply get the derivative of the equation. Thank you.
So, my name is Mat183. My matrix number is 2025194501, and I'm gonna solve question 4. For question 4, we must determine the estimated value by using linear approximation. So, the formula we'll be using today is fx approximately equal to fx naught plus f prime x naught multiplied by delta x. So, first of all, we need to define the equation as x. So, let fx equal to x squared minus cube root of x, and we will rewrite it as x squared minus x to the power 1 over 3 to make it easier to us for differentiate. Step is to find f prime. To find f prime, we need to differentiate fx. So x squared minus x to the power 1 over 3 will differentiate and will become 2x minus 1 over 3 x the power of negative 2 over 3. So next, we're going to find x naught, and delta x. So x, we already know the value is 8.02. For the x naught, we need to find the closest number to the original x to make our calculation easier or simplify. So in this case, we're going to use 8.0. Next, to find delta x, what we need to do is x minus 2 x naught. So 8.02 minus 8.0, we got 0.02. So after we got all the things that we need to insert the formula, we're going to insert it. So the formula again is fx approximately equal to fx naught plus f prime x naught multiplied by delta x. So we already know the value of the delta x is 0.02 and the value of x naught is 8. So for the f x naught, we got x squared minus cube root of 8, while f prime x naught, we got 2 times 8 minus 1 over 3 times 8 the power of negative 2 over 3. Then the f prime x naught, we need to multiply it by delta x, that is 0.02. So we calculate it, 62 plus 15.92 multiplied by 0.02, and the answer we got is 62.32. So the estimate value of 8.02 square minus cube root of 8.02 is 62.32.